In this video, I'll give an introduction to embedded C programming language. I'll also explain the difference between C and embedded C. What is embedded C? Embedded C is an extension to the C programming language. Some extra features are added to make it suitable for the embedded system software development, such as basic IO hardware addressing, accessing address space, etc. Embedded C uses most of the syntax and semantics of a standard C. So most of the syntaxes and semantics of a standard C are also valid in embedded C as well. While writing a C program, the system hardware knowledge is not required. But for embedded C programming, the user must have good knowledge of hardware. Specific compilers are required to compile embedded C program. The C compilers generate operating system dependent files, while the embedded C compilers generate hardware dependent files. So for example, so for example, the program written for Atmega 16 will not work with 8051. So the compilers generate hardware dependent files. So we need separate compilers for Atmega 16 and 8051. The C is used for general purpose PC and desktop based application, while embedded C is used for specific application. For example, robotics, UAV, etc., where number of tasks are limited or number of operations are limited. And these applications are based on microcontrollers. So based on the application, the C is used for general purpose applications, while embedded C is used for specific applications. Let's understand the program structure. First, we have to include header files, then we have to include function declaration, then main function, and then function definition. So the program structure is same as we use in standard C. Now let's take an example of basic IO port programming. The task is to load 0xFF into port A data register and 0xFF 0x22 in port B data registers. So this example is specific to the Atmega 16 microcontroller, where we have four ports, port A, B, C and D. Corresponding to these four ports, we have four registers, port A, port B, and port C and port D. Now in this example, we have to load this value into the port A register and 0x22 into the port B data register. Now first we have to include header file specific to the microcontroller. Then we have to write a statement port A is equal to 0xFF and port B is equal to 0xFF. So this statement, execution of this statement, the port A contains this number 11111, and then port B is equal to 0x22. So port B will have this value 0x22. Now let's understand one more example. Write 0x0f to the port A pins. Now in this example, we want to write data to the port pins. Port A contains 8 pins. PA0 to PA7. Now we want to write 0x0f to these port A pins. So first we have to include header file, then we have to configure the port pins in the output mode. To write data to the port pins, first the pins must be configured in the output mode. So to configure pins in the output mode, we have direction control register DDRA. So we have to write DDR is equal to 0xFF. The DDRA will have 0xFF, 0xFF to configure pins in the output mode. Now we have to load data into the port A register. So port is equal to 0x0f. Now after execution of this statement, all the pins will have this value 0 0 0 0 1 1 1 and 1.